So continuing with the previous video, as I said that the current gain of the circuit, taking the source voltage into account or the source current into account, will be equal to the internal, the current gain of the transistor only if your source resistance is infinite. Okay, so we are done with the voltage gain, we're done with the current gain, we're done with the input impedance, and now the other parameter which is left is the output admittance. Okay, now in order to find out the output admittance is obviously what? It can be represented as YO. It is the reciprocal of the output impedance, that is ZO. Okay, in order to find out the output admittance, let us set the voltage source, input voltage source, that is the source voltage as 0 and ZL as infinity. So obviously it is the resistance which will appear at the output terminals. We are opening the ZL first, right? So actually, if we take a look at the circuit, the output impedance is the impedance which is obtained seen looking into the terminals 2 and 2 dash. So output admittance. So right now, uh, we know that the impedance Z0 will be equal to V2 by I2, and if we talk about the admittance, it will be equivalent to I2 by V2. Okay, now what is I2 equal to? I2 we already know it is equal to HF into I1 plus HO into V2. Okay, now let us take this equation and divide both sides by V2. So we'll get I2 upon V2 is equal to HF I1 by V2 plus HO V2 by V2. Let us add another page. All right. So it is like this. So I think first term is like this. Second term, V2 and V2 will get cancelled out, and I2 by V2 will come out to be HF I1 by V2 plus HO, because we cancel out V2 and V2. Now, looking at the input part of the circuit, you're only taking this Vs as 0 if Vs is equivalent to 0, because I've told you at the earlier only that we have set Vs as 0. So look at the input circuit, we can redraw it here. Vs is 0 but Rs is there, Hi is there, and input impedance Zi is there. This is Hi and this is Zi, and the current flowing is I1. Okay, or leave Zi. Why are we taking Zi? Let us take the voltage source which is already there, HR and V2. So we have Rs into I1 plus Hi into I1 plus HR into V2 equals to 0. So this is the KVL. So that is apply, I'll write here, apply KVL to input circuit with Vs equal to 0. Okay. Now I1 will be common in two terms, that is Rs and Hi. HR V2 will be equal to 0. From here, I1 Rs plus Hi will be equal to minus HR into V2, and the ratio I1 by V2 will be equal to, because we have to transpose V2 to here, minus HR upon Hi plus Rs. So this term I1 by V2. In this equation, say for example equation 5 was not known, and you will substitute this I1 by V2 into the equation 5. So what we'll get is I2 by V2 will be equal to HF minus HF HR upon HI plus RS plus HO. Okay, so we can again write it as I2 by V2, which is the output admittance, is HO minus HF HR upon HI plus RS. Now we can notice that in this output admittance, all of the H parameters are involved, HF, HR, HI and HO. But there is also a role for the source resistance. So if the source resistance is 0, then this will be purely based upon H parameters, right? And if the source resistance increases, then obviously the admittance is going to decrease. Yeah. And now the last term or the last circuit parameter, which is the power gain. Power is obviously V into I, and it is given by, the power gain is given by the output power by the input power, AP, A subscript P, that is the output power P out by P in. P out is the output voltage multiplied by output current, input voltage multiplied by the input current. We can write it also as minus I2 V2, because in place of IL I can write I2, and this is I1 and V1. So this will be minus I2 by I1, and this will be V2 by V1. So what I2 by I1 is our current gain AI, and V2 by V1 is our voltage gain AV. So we can keep the equation like this, or else if we want, we can express one of the voltage gain in terms of the current gain and write it as AP equals to AI into AI RL upon Z in. Okay, and this will be AI square into RL upon Zn. So if you have current gain, square it, multiply it by RL and by Zn. So this is how we can find out the power gain. So the five performance parameters for a transistor acting as an amplifier, we have found out. We can analyze it using the H parameter.